Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 10. Today we're going to learn how to use loops to perform repetitive tasks because we're lazy bastards, as all good programmers should be, to a certain degree. But first, let's take a look at the schedule for the next few tutorials. We're going on what I like to call the Oreo cookie system, biscuits and cream. For those of you who live in weird places that don't have Oreos, I feel sorry for you. They look like this and they are fucking delicious with milk. So today's topic is loops. This is going to give us instant gratification and increase what we can do. That's sweet, sweet cream. Immediately useful. Well, the last tutorial was a biscuit. The topic was classes, and that's more like structure and architecture stuff. Maybe a little dry, but it holds the cream parts together, and you can't have a cookie without it. In the next lesson, we're going to learn about references, constructors, and data hiding. And that's mostly another biscuit, structure and architecture stuff. After that tutorial, we're going to learn about arrays, which is more power and gratification, cream time. Then in tutorial 13, we'll make a game, probably a snake game. This isn't really cream or biscuit. I would liken it more to like a slice of Costco pizza, which I fucking love. Hey, don't judge me, you pizza hipsters. It's fucking delicious. Alright, let's get started, shall we? Now we're gonna step away from the poo game today, but don't worry, we'll be back. I've got a fresh framework solution here, and we're gonna do some lines, baby. Winning! So if I asked you to draw a line that's 5 pixels wide, you'd probably say, Chili, I got this. You'd copy pasta up something like this, changing a few of the X values, and all's good. You get a nice stubby line at 100, 100. But what if I said I need a bigger line, like 500 pixels wide? You'd probably say, Chili, you know, I like you. I really respect what you're doing here. Go fuck yourself. And that would be the correct response if I were asking you to do some copy pasta bullshit. But we can do better than that. We have a smart, lazy way of handling this situation, and it involves something called a loop. So we're going to create a variable here because we like them. We'll create a bool, we'll call it flag, and we'll set it initially to false. Then we're going to type while, and we'll notice that that turns blue, meaning that it's a special word. And in fact, it is a statement like the if statement. It's very similar, in fact. Put a put pixel inside of there, and Bob's your uncle. So while is a lot like an if statement. Let's see how that works. We're gonna put a breakpoint here. We'll put it up there. I don't know. It doesn't matter. We're gonna set ourselves to debug, and we're gonna run the debugger. And when we do that, we're gonna break here, and let's see what happens when we step over the code. So we step over this. We get to our. I can't even show me my variables, bitch. Where's my autos? There we go. All right. So take a look at this. We see the flag is false, and we're going to step over this line here. What's going to happen? We're going to skip all this bullshit, which is what would happen if this were an if statement, right? We would skip this code because the expression inside of here is false. Likewise, if I set this to true and I run it, what do you think is going to happen? It is going to enter this code block here and execute the put pixel. Now, after it does that, this is where things get interesting. Normally, if this were an if statement, it would just go on its merry way. But this is a while loop. So what it does is after it executes this code, it goes back up here and takes another stab at it. So it checks this expression again. And if it's true, which it is, it's going to do this again. It's going to go back. And again, it's going to check, execute.
Going back for more.
Check, execute. And it's going to keep doing this until this becomes false, which is, as you can see, never. So this is an infinite loop. This freezes our program. We can see this. Let me just take off that breakpoint. You see, we're frozen. We can't see anything. You might say, well, Chili, but we're doing the put pixel. Why can't I see the put pixel on here? And the reason for that, I can't even fucking close this motherfucker. So I got to stop debugging. Yeah. So the reason why we can't see that put pixel is because we never leave compose frame. So the stuff that we're drawing never gets presented to the user. All right. Now let's try this again. This time we're going to go inside, we're going to execute the code. But now when we go back up here to the control expression here, I'm going to set the flag to false. And you can do this. You can set variables in memory with the debugger and change them. So now it's false. And if we try to execute that, you see that we exit and we go on our merry way. Beautiful. So the while loop is exactly like the if statement in that if the expression is true, it executes the code, and if it's false, it skips the code. The only difference is that if it executes the code, instead of continuing, it goes back and checks the expression again. Now, doing the same put pixel call, the same location, and the same color over and over again is pretty fucking useless. It's no different whether you do it once or a million times. It's going to have the same result. So what we want to do, what we can do, is we can change every single iteration of this loop. And a loop iteration is one run through the loop. So one test and one execution of the control block is considered one iteration. Now, here we're doing the same exact thing every iteration, but we can, for example, let's set a variable. So we'll set a variable x, and we're going to use x as the value that is being passed for the x position of the pixel that we're going to put on the screen. Now, here's where the interesting thing comes. If we just did this, there would be no difference between what we had before. But every iteration of the loop, every time we execute the loop body, we're going to increase x by 1. And now you see we're doing something slightly different every single loop iteration. And this should allow us to draw a horizontal line across the screen. So let's check to see if this is what's going to happen. We're going to run our debugger. And you see here we execute the code, we put the pixel, we increment x by 1, and then we go back here. We check, we put the pixel and x by 1 again. And we keep going. And we are now drawing pixels across the screen. All the way across. In fact, too far across, because there's no stop to this loop. It's an infinite loop. We're going to keep going right, and eventually we're going to go off the edge of the screen. We run this. Yeah, we get an assertion failed. X is not less than screen width. That's a problem. Now, what if, instead of controlling this while loop with this variable, we control it with the same variable that is controlling where we do our put pixel? So here, let's say we want to draw pixels from 100 to 599. So what we're going to do is we're going to do while x is less than 600, draw the pixel. And this will be true until x becomes 600, in which case it will be false and we will not execute the code. And if we run this, now we get a nice line 500 pixels wide. No copy pasta required. We can get rid of this. We don't need that anymore. Now, there are all sorts of different kinds of loops. You got fruit loops, fruity loops, you got loop-de-loops. You can't use any of those in C++. But what you can use is something called a for loop. So this is a for statement, and it does exactly the same thing as the code we had previously with the while loop, only it does it in a little different form. Now, the for statement has 3 different parts, and they're separated by semicolons inside of the statement, inside of these parentheses. The first part is the loop initializer, and it does the same thing that we had up here, where you can set loop variables and give them initial values. The second part is the loop control, and this is the same as the expression inside of the while parentheses, and this controls when the loop finishes. And the final thing you have here is the I don't know what the fuck you call this thing. Just call it the incrementer. And it is a task that is performed every iteration after the code has been executed. So what happens is when you enter a for loop, first thing that happens is you initialize your loop variables. So you execute this part of the loop. Then you execute the test. If the test passes, you execute the code. And after you're done executing the code, then you execute this expression here. And then you do the test, execute, increment, test, execute, increment until the test fails, and then you skip this code and you continue on. So all a for loop is, it's just basically a more compact way of writing this code with the while loop. But for loops and while loops are basically interchangeable. For example, if you delete this, and you delete this, and you go here, and you add an x variable up here, and you put an incrementer statement down here, you've got basically the same thing you had with the while loop. So you can omit the initializer part, and you can omit the incrementer part of a for statement. But you can't omit this. You got to have something in here. Something has to control the loop. Now, while we're on the topic of shorthand, let me just show you one little trick here. When you want to increment your x variable, you can do x plus an equal 1. That's fine. But there is another operator called the increment. And increment will just add 1 to whatever it is. It's a unary operator, so it operates on one operand, and it just increases its value by 1. No big deal, just another way of writing this. Now, you can put the two pluses in front of the x, or you can put them behind the x. And it has a slightly different meaning. There's a very subtle difference between these operators. This is the post increment, and this is the pre-increment, and I'll talk about that a little later. It's not a big deal, though. You could use either one here. It wouldn't make a lick of difference. But for now, we're just going to stick with pre-increment because it has advantages in certain specific situations. Here's a fun, chilly fact for today. The name of the programming language, C++, its name is derived from the increment operator, because C++ is basically the next step up from C, so it's C++, it's C incremented, it's the next level. That's the name. I guess they chose that because D was already taken. You can take my D. I'm sorry, that was uncalled for. One last thing I'd like to note about the for statement is the loop variables declared inside of the for statement, their scope only lasts until the end of the for statement. So if you tried to do like x here, the compiler would complain because it's no longer defined. All right, there's one more kind of loop in C++, and I'm going to go over it for, completeness sake, but I don't use it very often. It's called the DoWhile Loop. And the way it works is it executes this code, and then it does the while check. And if the check is true, it goes back and executes it again. So it's very similar to a while loop. The only difference is that this one will execute the code and then do the check. So it's guaranteed to execute the code at least once. Whereas the while loop may fail the first check and never actually execute the code here. So if you want to guarantee that this code will be executed one or more times, you might want to use the DoWhile loop, but I don't generally use them. I stick to the while loops and the for loops. And they're both, interchangeable. You can do anything you can do with a while loop, you can do with a for loop and vice versa. So the way I generally organize it is a for loop is like a kind of counting loop. You have a specific start and an end condition, and you're just iterating, you're stepping through it. Whereas in a while loop, you're waiting for some condition, some flag to become false, and you're just executing it over and over again until it's false. So in a while loop, generally, you're not sure how many iterations you're going to have. You're just waiting for some condition. Just as a quick example of this, if you go into main.cpp, ignore this try and catch bullshit for now, and just look at the while loop we have here. And what this one is saying is, as long as process message returns true, execute a frame of our game, and just keep doing that until process message returns false, and that means it's time to quit. And so we exit the loop, and that will exit the program. So in this case, we don't know how many frames of the game we're going to execute. The user might close the program after 2 seconds, or he might close the program after 2 hours. So this would not be a good place to use a for loop. I would prefer to use a while loop in this situation. Whereas in the situation of, for example, drawing a line, we have a definite start and an end, and so I would prefer to use the for loop. It allows us to put our incrementer and our initializer in a nice place here. Doesn't clog up our code. It's just a perfect fit for this situation. And that'll about do it for today's lesson on loops. Now it's time for another installation of Chili's Dank Nugs. So here we are, lesson 10. I hope you've been practicing and experimenting on your own. Over the next few videos, we're going to give you even more tools that will enable you to do a bunch of dumb bullshit. What I want to talk about today is the optimal way to view these tutorials, because there is a right and wrong way to do this. Now, the wrong way is if you're watching the video and as I type code, you're pausing the video and typing in what I do. Just monkey see, monkey do the whole goddamn way through. That's not good because you're not actually thinking about things yourself. You're not struggling to remember what you were taught. You're just copying what you see on the screen. It's going in your eyes, out your fingers, and it's not stopping anywhere between in the gray matter. And that's a problem because then you're not building those neural circuits that you're going to need when you want to code up your own shit. So here's the recommended Chili way of watching the tutorials. You're going to watch the video through once or maybe twice if you don't get some things. And then you're going to set the video aside and you're going to try to do this on your own without peeking at the video. Now, this is going to be a lot harder, but that's the goddamn point. No pain, no gain, or so they say. So you watch the video through once or twice until you're confident that you have, most of the concepts understood and under your belt. And then you close the video and you try to code it up, at which point you realize, oh fuck, I forgot where this goes. I forgot, the order of expressions in the for loop statement or whatever. And then, you're going to bumble through. It's going to be hard, but you're going to make progress and you're going to get way more knowledge than if you just fucking monkey see, monkey do that motherfucker. Now, if you get, super stuck and you just don't know, you can go back to the video and look. I mean, it's a better option than just, fucking giving up. I prefer, though, instead of going back to my video and trying to copy what I did, is if you get stuck, open up the Google monster and start Googling Google C++ for loop and do some research on your own. Because it's good practice. In the future, you're not going to have tutorials to show you what you want to do. You're going to be beyond the point of tutorials. And when you get stuck, when you don't know how to do something, you're going to need to be able to use Google to find that information. So if you get stuck, first resort is try to figure out on Google. Second resort, the final resort, is go back to the video and see what I actually did. So to summarize, first thing you do, you watch the video. Then you close the video and you try to code it up yourself. Occasionally, maybe looking things up on Google or, on Chilipedia or whatever. Or if you have to, referring back to the video. Then you do the homework. And once you got that all squared away, then you got to experiment on your own and, maybe make some fun shit. This is the optimal workflow for becoming a C++ sex god. Dig it. All right, now it's time for the homework. Today, I've got something for you, a little interesting, a little useful. What I want you to do is I've shown you how to draw a line. Now I want you to draw a rectangle. So you're going to use the concept of looping to draw a rectangle on the screen like this. So that's task 1, draw a rectangle. Now task 2, if you have finished task 1 and you want something a little more interesting, you can make it so that you control the rectangle with the arrow keys. So you can control the position of the rectangle with the arrow keys. And you can control the size of the rectangle with the WASD keys. So here I've got my rectangle. I can resize it and I can move it around using the arrow keys and the WASD keys. And that's task 2. Now in the tutorials, I haven't yet shown you how to check alphanumeric keys on the keyboard. But the way you do it is, for example, for the D key, what you're going to do is you're going to do key is pressed as usual, but instead of VK something, you're going to do single quotes around a capital D, and that'll allow you to check the D key. And it's the same for the other letter keys and the number keys. And this information is on the Chilipedia wiki. I'll put a link on the page for this tutorial, but I just wanted to let you know this is how you check for alphanumeric keys on the keyboard. And that'll about do it for this video. We can use loops to draw all sorts of shapes, not just lines and rectangles, but that's something for the future. Rectangles are going to be useful to us when we make the snake game for sure. And loops are also going to work together with the future topic of arrays to do something that's just fucking amazing. So stay tuned for that. But until next time, thanks for watching, and a special thanks to all my supporters on Patreon. Love you guys. And I'll see you next time with some more C++.